All right, so for this particular question, they've given us a voltaic cell, and we're asked to find the cell potential, but there's a little bit of a twist. They're saying that instead of using hydrogen, the hydrogen half reaction as our reference cell with a value of 0 volts, we're going to change it so that the standard cell is the lead half reaction. So we'll get to that part in a minute, but for now, what we need to look at is the actual voltaic cell. I've got 2 half cells here. I need to figure out what's my cathode, what's my anode. So I've got the species present over here. This is a strong acid. So when we list our species present, we separate it into hydrogen and nitrate. And then on the other side here, the species that I have present, I've got a copper nitrate solution. So I have copper solid, copper 2+ ions, and H2O. I also have nitrate, but I've listed that over here as well. If we go to our data books and we look for our strongest oxidizing agents, so starting from top down, the first one that we see of our entities present is NO3 and H+. So together, those act as our SOA. The SRA in this reaction, if we start from bottom up, the first one that we see is solid copper. So this is our SRA. Now what we want to look at, so I've got the SOA, strongest oxidizing agent is reduce. Reduction happens at the cathode, gain electrons, reduction at the cathode. So here's my cathode. This is my anode. To calculate the cell potential, we take the value of the cell potential of the cathode minus the anode. But there's a little bit of a twist. We have to adjust the values to base it on having lead as our standard half reaction. So we'll set up the formula. Potential of the cell equals potential of the cathode minus potential of the anode. Go to your data book and take a look at the values. So this, in our data book, we're using hydrogen as the standard reference cell, right? It has a value of 0. What they're saying is instead of hydrogen, let's use the lead half reaction as the standard. So the lead is at a value of 0.3, or negative 0.13. But let's shift that and make this 0. So what I've done is I've increased this value by 0.13 volts. That means that everything else on the chart from top to bottom is going to increase by that same amount, right? So I'm going to take my SOA, and the value of 0.8 is going to become positive 0.93. I'm going to increase it by 0.13. And my SRA, so this value of 0.34, is going to increase to become 0.47. So now we have our new values. I've got positive 0.93 and positive 0.47. So if we go back to our formula, E of the cell is positive 0.93 minus positive 0.47. And this will give us a value of positive 0.46 volts.